what starting value would result in timer 1 run over in 3 milliseconds. So first, 3 milliseconds is less than 4.1, right? It's assuming one-to-one pre-scalar, so it's not getting divided. So we can refer to this time as less than this time, which means we don't have to roll it over, right? So we just need to give a little offset in there, which is starting value. So which means, right, give something over here, and this is gonna be 3 milliseconds. So it's asking for the starting value this time. So 2 to the 16th minus x, right? X. Here's x. That's the remaining counts divided by 16 times 10 to the 6. All right, this equals 3 milliseconds. Any questions by far? Cool. I'll give you a few seconds to calculate it. What are we getting? Cool. Any questions on this? All right, let's move to the next. How many timer 1 counts occur in 1.5 milliseconds? It's still smaller than 4.1 milliseconds. So it's not rolling over. It's still within the counts, just the first cycle. So 1.1 times 10 to the negative third, that's the time, right? Seconds times 16 mega counts per second. So we got a second, the time getting canceled, and eventually giving you a number of counts over here. Number 5. How many times would timer 1 roll over in 100 seconds? 100 seconds. That's pretty long. This may happen to some field deployable sensors and being powered by solar panels and have limited resources of power supply. And you are measuring some environmental data, you want to send it over to a data center, every several minutes. That's reasonable, right? Now, you're not expecting the temperature or anything else is changing at 100 megahertz. You're not measuring that fast. It could be a few minutes, you measure it. You got a temperature, humidity, or anything else, right? Your environmental data samples, and then send it. So you can put your microcontroller into sleep to save power, right? Whenever and every time after 100 seconds or a few minutes, you wake it up and transmit the signal. So what about 100 seconds? It's very long compared to the speed of the clock signal, right? So it's going to roll over for many times, and you need to write a little for loop, a little if statement, right? So whenever it reaches that many times, you do something, okay? So this one, so time is given, all right? How long it takes to roll over once? Right? That's how long it takes to roll over once. And that gives you how many times it's going to roll over within that time frame. This is seconds, this is counts. This is counts per second. So it's going to be second divided by second. You got second getting cancelled. So ends up with how many times. I think this is, I forgot. A few thousand times, right? It won't be an integer. For example, it's like 4414.04. I don't know. I'm just guessing. And you know, just take out the integer part, right? This is how many times roll over, because this is, it's still counting. It's not finishing that yet, right? That's just an estimate. It's not an accurate number. So you are the ones to calculate accurate number for this question. Any questions on this? Number 6, starting at 0, what values will be stored in timer 1 after 10 milliseconds? 10 milliseconds is longer than 4.1, so I'm going to roll over for twice, and then stop in the middle somewhere for the third cycle. Okay? How do we calculate that? What value is asking for? What value will be stored in timer 1? Where it stops at? I'll give you a few minutes to do it. Is that okay? How do we do that? 10 milliseconds minus what? Minus how long it takes to finish it, right? Wait. 10 milliseconds. I'm going to divide it. I'll divide how long it takes to finish one cycle. So which is giving me, it's giving me a integer and fractional number, right? I don't know, let's say 2.6. 2.6. So which means it rolled over twice and then reaches 0.6, 60% of the counts. Okay? So how many counts do you have in total? Then times this fractional number. So give you what the number is at. Make sense? It's counting twice and then reaching the 0.6. That's 60% of the counts. 60% of the counts. So 60% of the counts, you totally have 2 to the 16th for total number of counts, which is 65536, right? Then times this fractional number, you are reaching that count at 10 milliseconds. Any question on this? The better way to calculate it?
Say that again?
Say that again. So 10 milliseconds is longer than 4.1 milliseconds, which, so 4.1 is an estimate of how long it takes to roll over once. Okay? Because you total have 2 to the 16th number of counts divided by the frequency, how fast it counts. Just giving you that it takes 4.1 milliseconds to finish the counts of the 16 bits once. Okay? Once. So now, it's given that it's 10 milliseconds, so know that this is larger than 4.1, and I'm using this 10 milliseconds on the top, divided by how long it takes to finish one cycle. So I'm getting how many cycles is going to happen within 10 milliseconds. Because this is how long it takes to finish one cycle, right? And this is how long, this is 10 milliseconds of time, overall time. So the total time divided by how long it takes to finish one cycle is giving me how many cycles will be done within 10 milliseconds. So it's gonna be 2 point something, for example, 2 point something milliseconds, the 2 point something cycles, and get rid of the integer, only leave the fractional part. So which means it rolls over twice, and at the third time, the third cycle, it only finishes 60% of the counts. So I use this 60% times the total count. I can find out the count it's gonna be at 10 milliseconds. Okay? So if you still have questions, come back to the recorded video. So this is something you must know, okay? You will get credits from quizzes or exams in the future. Number 7, assume that assume that the counter is currently at this number, ABCD, as a hex number. How long will it take for the counter to reach 1, 2, 3, 4? It's going down. It roll over first, right? And then reaches 1, 2, 3, 4. How long it takes? How long it takes? So first you need to know it's currently at this number. How long it takes to roll over, right? So you have to, because now it's at, you have this remaining here. You have to finish that one first and then keep going to reach this. So I have to get this number of counts first. So that's gonna be, you have to use a calculator. Let me show you how to use it. Have you used that calculator in Windows before? Let me show you. Maybe make it bigger. Sorry for that. So first, go to Programmer and click Hex. Click Hex. So you got ABCD. The hex number ABCD is actually decimal 43981. And then go back to scientific. Use this 2 to the 16th minus 43981. Okay, so this will be the number here, 21555. Okay, so first you got this number, and second, you need to find out this number. Go to Programmer, Hex 1, 2, 3, 4, which is 4660. So that's the total number of counts to finish. And you know the frequency, right? You know the frequency, so you can easily find out the time. Does that make sense? But for the programming, you have to write an if statement. So if it overflows, you got the flag on, and you need to clear the flag, and you add a 1 to the counter, and then start over the timer and do the counts again. So that's why if it's just overflowing once, you just use a prescaler. Yeah, just use a prescaler. Do it.
Quick question.
What's that?
It's starting at a bigger number and it's counting down.
Yeah, it finishes all the counts first, and then start over from 0. It's counting from 0 again. From 0 to this, right? So this from here it reaches 2 to the 16th first.
So it's like all the counts then? That takes, so from like the counts going from ABCD to 0, and then from 0 to ABCD4.
Yes.
Like you have those together?
Yes. So that's why we use 2 to the 16th minus this number to get the remaining counts in the register, and then we add this one, which is a new set in the new cycle, which needed to be counted. right? It's a new number, so we add them together to find the total counts. Okay, let's add one more. No, let's see. That's okay, just leave it here. Come back to page 1. Any questions by far? Should we move forward? It's a lot better this time, right? Monday was too fast. So look at these ones. Remember the I think we probably want to look at the result first. What's that?
Do we need to add 0 at the end? Like, do we need to add +1 to come to the 0?
You don't have to worry about that because it's running at 60 megahertz, right? So all the little ones, you can just ignore them. Don't worry about that. So just follow the same method and just keep it consistent. For example, we know that it's reaching, we just use the maximum number 2 to the 16th minus this number, okay? Just minus it. If our, sometimes you use a bigger number minus another one, you probably have to add a 1 to it, right? We ignore that. We don't worry about that. So use this one minus this one, you get a remaining number, and then just regularly add to the new one. That's it. Okay. So the final result of tutorial 2. Quick update. Right, quick update. I just sent an announcement before the class. So we have tutorial 2 for this and next week, and tutorial 2 has a lot of I have a code which is given in tutorial for task 1, but for task 2 and 3 it's not given, so it's probably can be a little bit complicated for you guys. It's a challenge, so you have to take the time to get it done. You have to go to the lab and do the programming. And so you have to post your code to the report, and I'm looking at your code. So the code, if you write it by yourself, it's going to be very different from individuals. Okay, so don't duplicate other people's code, and you will get a warning and get a 0 at the very beginning, and the next time I'll just fail you from the class. So because this is very simple, the board is already soldered. You get a code, you download it. Just take 2 seconds to duplicate from other people's. You can ask other people for advice for any ideas, but never have the same code on your assignment. Make sense? Okay. Don't share. If you share, I see similar code, I will do the same thing to you as well. So never share your code with other people. So make sure everyone can. Because this happened last year to the other school. I mean, people on the same team, they duplicate. A lot of people, they finish the class, but they still don't know how to program microcontrollers. Okay, so I want everyone knows how to do it exactly. I'm giving you a lot of time. You see, I assigned it on Monday, right? So it's due next Friday. So I think I will probably keep doing this for the following weeks. So it's basically giving you about not exactly 2 weeks, but 1.5 weeks at least, for you guys to design your own code, to make it happen. What's that?
You have the assignment due the 24th in Canvas.
Yeah, I'm gonna change it. I just updated. It's gonna be 26. Okay. So
in general, should we follow your website more or Canvas?
this is not giving you the assignment itself, right? Just a note, because every time I open this up in the class, everything's here. It's easier to go through. It's better organized, I think. It's like a calendar. Yeah. Tutorials are here, and I will give you the links to the tutorials in Canvas, but I have to follow the deadlines and everything in Canvas. Okay. So next Monday, I'm going to introduce a new tutorial, which is similar techniques, but more complicated. It's going to be a music box game. I'm going to post it in 1 or 2 days. And Wednesday and Friday, I don't have in-person lectures, and I don't think we need any recorded lectures. If you need some instructions, I can probably record it and post it. I have to travel to New York City for IBM conference for the quantum grant, so I won't be here. So no office hours as well. So you guys are supposed to work in the 16 lab, right? To program and get things done. And the new assignment for tutorial 3 is due 3 weeks from now. Okay, and whenever I feel like there are too many assignments and you guys are struggling, I will just slow it down. But now it's still, I think it's still okay. I'm gonna help. There are probably maybe 1 or 2 more boards are still not getting finished yet. I'll help with that a little bit, and then everyone can get on their speed, getting things done. So the goal for this tutorial, let's go to the final result first. So the final result is you have to play music automatically with the microcontroller. It's a Twinkle Twinkle Little Star with a very weird break in the middle, and you can change it. I just don't care, but see. Right. So press the button to start the music, and you can find different music notes or scales from here. Kit songs. There are all different options, or you can just directly use whatever I did, because all the counts translated from the frequency of the notes has been developed. So I already posted here. Wait, did I? No, I haven't. Okay, so in that case, it's going to be the same. If you pick up a different song, it's going to be the same amount of tasks and efforts. So let's come back here. Right, come back here. We were at so this is timer, counter. I don't have the first one. Timer, counter, controller. You can take pictures. You can take pictures of this. Timer, counter, controller, register 1, B. Okay? What are the lower 3 bits do in this? That's a must know. What is that? That's the prescalers. So the names are CS, something, something, right? So what is the first something? Timer. Great. Thank you. I feel so good. I did a good job on Monday though. So CS, something, something, the first something is the timer. The second is what? The location. Okay? So the CS 10 means what? Yeah. It's the CS, the timer 1 is prescaler, but location 0. It's a bit 0 of the that register. So the CS bits, the prescaler controlling bits, are within that register. It's taking the 3 lower bits of that register. There are other bits over there for other 5 bits, but we're not there yet. I mean, there are more control capabilities, but we are not modifying them yet. So this guy, if you give a, how many bits are in here? How many bits? It should be a no-brainer. It's 8 bits. Because all the control registers are 8 bits. Because this is the 8-bit CPU. Okay, it's 8-bit CPU. So all the control registers are 8 bits. Why the counting register is 16 bits? It's a special. It's a counting. It's used for counting. It's not a control register. Right? It's a different one. But also it has 2. It's a TCNT. This guy is actually TCNT high 1, TCNT low 1. It's actually 2 8-bit registers. It's not really a 16-bit memory bank. It's actually 2 8-bits. So it's all of them are organized in the 8-bits format. Okay. So this guy, if I want to stop the timer, what should I do? Assign 0x00 to it, Remember, this is the hex number. This is 4 bits, so it's total 8 bits. So which means I'm giving what? I'm giving 000 to the CS bits. So the CS bits, if you keep all zeros, it's actually stopping the timer. There's no prescaler. I mean, it's not even 1-to-1. There's just no prescaler at all, right? So, and we are using this command to stop the timer. And then if you want to start a timer, you give us, and you want to use a 1-to-1 prescaler, what you want to do? What's the command? What's the code? 1-to-1 prescaler, and you want to start a timer. Which number you want to put into this register? Prescaler 1-to-1. Clock signal divided by 1. No prescaling. What number you want to put into this register? So see, CS12, CS11, CS10, right? Which number should be here at least? No, prescaler 1. See? 001. So this has to be 001, right? And for the rest, we don't care about them for now. Just give zeros. So what code to be putting here? Should be putting here. To start it with the prescaler 1. Which code? This stops it, right? How do you want to turn it on? And with the 1-to-1 prescaler? Yes. So this is 0000. It's hex number, okay? So this is 0001, right? And that 3 bits are the CS bits. Okay, so this register is very clear right now for us. And when the counter overflows, so it starts counting from 0. If you put a 0 into the TCNT register, right, it starts counting. And when it finishes all the 2 to the 16th counts, what's going to happen is this guy is a timer interrupt flag. So interrupt means it interrupts, right? So whenever it's overflows, it interrupts, it stops. So there's a flag register number 1 for timer 1. And that register has 8 bits as well, and these bits are not being used, and these are some functional bits, but we don't care for now. But what we care is TOV1, which is timer overflow timer 1. So that's the LSB of this TIFR1 register, and that one will automatically being set whenever it overflows. So that's a signal bit. So that's how we know it finishes the 2 to 16 counts. So this one becomes 1, and there's one thing really confusing. This is my first time knows this. I mean, whoever designed this microcontroller many years ago, they designed it that way, which is fine. But I'm assuming there's a XOR gate in there, but I'm going to show you why. Okay. So whenever TOV1 becomes 1, it finishes the counts, and if you want to clear this bit into 0 so it can start over again, you want to write a 1 into it. I don't know why. You write a 1, you put a 1 into that bit, it already has a 1, right? Already has a 1. And then you write a 1 to it, it becomes 0. How could that happen? The only thing I can imagine is it's not directly writing into that bit. What's happening is that TOV bit, okay, TOV1, right? So this guy, whenever it finishes, it has a 1 here, right? It has a 1. So when you are doing that assignment to this bit, it's basically doing XOR logic. So this is your 1, right? The 1 will be XORed with the previous 1, and eventually resulting in a 0 and being put into this register as this bit. Because one XOR with 1 is 0, right? But why does it have to do that? I don't know. I mean, all the other microcontrollers, you directly just put a 0 into it. You just clear it, right? But this is weird. This is like you put a 1 into it, then it clears and becomes 0. Okay, let's just remember that. So this answers this, right? This is a timer interrupt flag register 1. This timer 1 overflow. This is LSB. It's easy peasy 3 points. What is TCNT1? Why there's a TCNT1H and one TCNT1L, right? So these are the higher A bit and lower A bits to form that 16 bits of the counter, because this timer 1 is a 16-bit timer. Okay, and the LSB, just put another answer over there for another question. So the LSB of the TCNT1H represents what? I'll let you write it down. Okay, so the LSB of this register represents what?
2 to the 8.
Yeah, I'll let you guys write it down on the paper. Okay, I'm gonna grade it. How to reset TOV1? I already told you. Yeah, write a 1 to it, right? Write a 1 to it. That's weird. Weirdest thing of the year. Oh, it's done. It's everything. So let's see how long it takes for over. Same question. What the counts would be after 2 milliseconds. Okay, so I mean, we don't have time in the class today, but I'll let you guys finish these 3 questions and take a picture or scan it and submit to Canvas. Is that okay? I'm gonna change the assignment to a Canvas assignment. Is that okay by the end of today? Okay, sure, let's do that. So that's 2 assignments, I think, 2. So the first one is for the in-class exercise 2. And the next one is 3. It's two assignments. So it's both due tonight, okay?